Are we on now? Hey guys out back in the snacking area, feel free to migrate. All right, Lauren has closed the gate. Howdy, y'all. My name is Jeff Peterson. I'm the GRIDSMART sales manager for Texas, thus the greeting. I'm very excited about introducing our next keynote speaker today. He comes from an academic-ish government institution. He's going to talk a lot about that, but as a change of gears from our prior speakers this morning and yesterday, he has a pretty extensive federal government and legal background. So in the backs of everyone's minds in your agency careers, I'm sure a lot of you have questions about how the legal professions are going to impact the way forward on technology and integrating it in our future. So I think Greg will have plenty of thought-provoking thoughts about that. So it's my job to run around crop dusting around Texas, evangelizing GRIDSMART technologies. And when I started last summer, first 10 times around, I kept hearing from engineers, this product looks great. Has TTI tested this? What does TTI say about it? Does TTI like it? So after that happened several times, I'm like, man, what is TTI and who are these influential people? Well, Texas A&M Transportation Institute, or TTI, is a Texas state agency and the largest higher education affiliated transportation research institute in the United States. Our next keynote speaker, Mr. Gregory Winfree, is the current director of TTI and leads a staff of over 600 professional researchers and students with annual research spend of over $60 million spread across more than 700 annual projects. Under his direction, the agency operates 11 facilities in Texas, Washington, D.C., Mexico City, and Doha, Qatar, that support research projects in all 50 states and more than 40 countries. Mr. Winfree has been agency director since December 2016 and previously served in the U.S. Department of Transportation's Office of the Assistant Secretary for Research and Technology, first as chief counsel in 2010, then being sworn in as assistant secretary in January 2014. In this role, he oversaw a $450 million budget and over 1,000 scientific, data analysis, and administrative employees who supported U.S. DOT's multimodal transportation initiatives. Prior to his time with U.S. DOT, he enjoyed a 17-year career as general counsel to several prominent Fortune 500 companies, including Freeport-McMoRan, Wyeth Pharmaceuticals, and Union Carbide Corporation. Mr. Winfree has a bachelor's degree from St. John's University and received his law degree from Georgetown University. He has assembled a talented team of thought leaders who will help guide us to a more connected and efficient transportation future. When you visit TTI's Rellis campus, it even feels like he has turned College Station, Texas into the Los Alamos of transportation. Please help me welcome the Honorable Gregory Winfree.
Well, howdy, everybody. Okay, now see, I'm from New York, but I've been in Texas now for 3 years, and the official Texas A&M greeting is howdy, but it requires you to emphatically say howdy back. So howdy, everybody. Howdy. Now we can get started. Thank you so much for playing the game. It's great to be here with you. The only thing more challenging than being the speaker right before lunch is being the speaker right after lunch. So please try not to nod off. I may call on you. I am, again, a lawyer, and I remember my early years as a law student and the terror that the professors would inflict, but I'll spare you from that. So this is our title slide, of course, Connected and Automated Vehicles, and it's all about research and testing Texas style. So what exactly does that mean, and what does that look like? So a little bit of background. TTI was established in 1950 to conduct transportation research to assist the Texas Highway Department, that was the name of TxDOT at the time, in the effective development of the state's roadway system. In addition to being one of the 8 state agencies under the Texas A&M University System umbrella, TTI is part of the system's engineering program and helps train the next generation of transportation professionals. Now, in the early days, TTI focused on civil engineering-related highway research, highway infrastructure, pavement, roads and materials, bridges, structures, and how to keep drivers safe on the roadways. So interestingly, some of that historic photos you can see, those of us who remember iron bumpers into iron barrels, That was kind of how this crash survival technology all got started, pre-seatbelts, right? So it was all about the first 50 years of vehicular innovation has been about ensuring that vehicle occupants survive crashes, right? But why we're here is the next 50 years is about avoiding crashes altogether. And just some of the other pictures, that's I-635, a project for which we're working with TxDOT, providing some technical support. And then that's an instrumented bridge deck you see on the upper right. And yes, you can stand up. Well, if you're over 6 feet, maybe you need to crouch a little. But it's a bridge deck that allows us to test strain gauges and other kinds of stresses on structures, as well as utilizing the guardrail system for testing the ability to keep vehicles from going over these kinds of devices in impact scenarios. So our current research emphasis, TTI's research program has grown significantly throughout the years, and today is multimodal and focuses on many other areas. We're fully invested in forward-thinking transportation technologies and connected and automated vehicle research. We're also preparing our physical infrastructure, such as pavement markings, signs, signals, roads, and bridges, for these connected and automated vehicles. Also important to the equation is how human drivers will react to all types of vehicles as more automated driving technologies come onto our roadways. So that's a long way of saying we have a significant focus on human factors, right? So that's human-machine interface inside vehicles, as well as how do pedestrians and vulnerable road users react to the future mobility solutions that are coming down the pike. And again, just some of the pictures that are being depicted. You're all familiar with the connected vehicle, kind of radio waves coming from vehicles to vehicles. This dates back to I believe we got that picture from US DOT, from the ITS JPO, Intelligent Transportation Systems Joint Program Office, that used to be in my shop at DOT. The upper right is a machine visioning technology that we were testing on a Tesla Model X, right? So right now, automated vehicles principally navigate utilizing signs and lines, right? So the brighter the lines, the wider the lines, the better these vehicles can track where they are. So this was technology and trying to find that sweet spot from a daytime as well as a nighttime perspective, and also on light background materials. Y'all know about the challenges of these lines on concrete and other light roadway materials and whether or not the vehicles can pick them up. The lower left is a mobilized system on some of our campus buses. The drivers in the Texas A&M University system are all students. We don't have professional drivers. So these students get their CDLs, and they're the ones who are driving their fellow students around campus, as well as providing some municipal service for the cities of Bryan and College Station. And the device you see with the pedestrian that's walking, that's from Mobileye. Many of you are familiar with that company, but it provides 360 situational awareness for the drivers, which is important because as many of you who have visited university campuses, these kids come from the darndest angles on the darndest things with headphones on while texting. So in order to improve situational awareness and the safety profile writ large, that's what we've been testing as part of our campus transformational technology initiative. The lower middle, that's some work we were doing on perinasal stress detectors. That's part of our human factors research. So this particular scenario is monitoring eye movement, but also there are detectors that, for those who are familiar with how this works, if you are in a stressful situation, oftentimes your nose starts to perspire right up on your upper lip. Well, we have developed technology to be able to measure that and use it from a predictive analysis perspective. So this is a snapshot of our full complement of expertise at TTI. These are kind of our 12 discipline areas, but the power is in the ability to combine and move across disciplines. So it really is an unlimited potential and a testament to the brilliance that we have resident at TTI. So facts and locations, we have 7 urban offices around Texas. The star is Bryan, College Station, so that would make 8 with our headquarters. They address the transportation challenges of our state's most populous areas. We also have 2 staff members in Washington, D.C., and 1 in Mexico City, as well as a presence at Texas A&M Qatar through the Texas A&M University Engineering Program. The yellow dots on the map indicate where TTI is currently working on research projects around the state, so you can see how much of an impact we have statewide. The facts graph shows TTI's size related to staff and research projects and expenditures. And I think it's key to mention that 80% of TTI's funding comes from competitively procured sponsored research funding. So that means we get about 17% of our funding from the Texas legislature, and the lion's share of that is dedicated to 4 centers that they've mandated that we provide. So at the end of the day, we have about $2.5 million to run a 700-person organization, right? So we are eat what you kill. Our researchers kill something at the door, drag it across the carcass, drag the carcass across the door frame, and we try and feed as many people as we can. So it's an entrepreneurial environment. It's a dynamic environment. It's from a leadership and management perspective, it's a great pleasure to work in an organization where you don't have performance problems, right? Performance problems tend to weed themselves out and are no longer funded. So some of the issues I dealt with as a Fed, chasing civil servants around, I don't have to do that anymore. It's a great relief. But again, 80% of our funding comes, again, from competitively procured sponsored research funding. TTI is available to the private sector to assist with technology development and testing. And our staff comes from more than 50 different countries with multiple areas of expertise. And our students come to us from multiple departments at Texas A&M, engineering, landscape architecture and urban planning, the Bush School of Government and Public Service, and the Texas A&M School of Law. We also employ students from other universities throughout the state at TTI's urban offices. So for example, we have a center in El Paso that works on cross-border intelligent transportation solutions, and we use students from UTEP, University of Texas El Paso, as well as University of New Mexico. So that helps us achieve the requirements from the state for the funding that we get, that we're part of the enterprise that trains the next generation of transportation professional. So here's our global presence. TTI is an international research institution, and we've been working throughout the United States and around the world for decades. Since TTI's inception, our researchers have worked in all 50 states, Puerto Rico, and 51 countries around the world, with 278 private sector sponsors, in addition to our traditional public sector sponsors. So I think that just gives a great depiction as you stretch out the Mercator projection, I guess they would call it, of where we've been and how impactful we've been across the globe. So a little bit about the Rellis campus. You'll notice Rellis is all capitalized. That's because it's an acronym for the 6 core values of the Texas A&M University system. That's respect, excellence, leadership, loyalty, integrity, and selfless service. So we're proud of being able to capitalize that at our new campus. So new is relative. This campus was actually a World War II Army Air Corps base. It's a 2,000-acre collaborative environment for teaching, research, workforce development that blends industry expertise to shift ideas from the laboratory to the marketplace. So again, it was an Army Air Corps field built in, I believe, 1942, and the location has long been a place where Texas A&M and TTI have conducted world-class research, technology development, and workforce training in areas such as vehicle safety, traffic engineering, law enforcement training, biological materials processing, robotics, and unmanned aerial systems. Now, TTI itself has a multitude of testing facilities at the Rellis campus, including a roadside safety and physical security crash testing program, an emissions testing facility that can accommodate a semi-truck trailer and a full-size bus, a sediment and erosion control facility, connected and automated vehicle test beds, a connected roadway signs and markings test bed, and a world-class Center for Infrastructure Renewal. And that CIR, Center for Infrastructure Renewal, is literally a walk path from the TTI headquarters. It's a joint center with one of our engineering partners, partner engineering agencies that I'll mention in a minute. The upper left picture, that's the environmental chamber, as we talked about, where we can get full-size vehicles in there. It has dynamometers, so we can run them under stress and under load, and we can control the climatic conditions from humidity to temperature up to 140 degrees down to -20. So we can test all manner of vehicular applications, but also importantly, we can test devices. We've had companies that were installing, let's say, equipment cases in the desert Southwest that wanted to make sure that the coatings they had on the boxes wasn't going to delaminate in a heat condition, right, over time. So we were able to kind of test that for them and provide those challenges from an environmental perspective. In the lower left, that's kind of an aerial picture of what the facility looks like. We've got 7 miles of paved surfaces. Interestingly, because it was made in 1942 and steel was scarce, these runways have no rebar. They are 10-inch thick concrete runways, and you'd be stunned at the condition that they're in. They're in remarkably great shape, having now weathered 70-plus Texas summers, but that's literally where we do our dynamic road testing. And you can kind of see where the education campus, we have university partners from across the system. So the other 10 university campuses that are not based in College Station have a presence on this campus, as well as Blinn College, which is a 2-year college. So it's an educational continuum to take kids from high school all the way through to doctorate. If they choose a Texas A&M pathway, they can get an associate's degree. If it's adults looking to repurpose or retrain, we have the ability for that, as well as veterans returning from service that are looking to redeploy themselves. So the TTI Proving Ground, here's some photos showing the roadside safety and physical security testing underway at TTI's Proving Grounds. We call this the Crash and Bash team. This is what we're most known for. This is where the YouTube videos and other depictions of what TTI is all about, this is what makes us the most famous, because it's one of the few facilities in the country that meets federal highway standards for testing roadside safety equipment. So as you all know, the MASH handbook, the manual for safety hardware on our roadways, has been updated. Well, we are now doing about 150 tests on an annual basis of barriers, of bollards, of all kinds of equipment, cable barriers that you see on the roadways to ensure that they meet the new MASH standard. So we've leveraged our roadside safety and perimeter security research also into a relatively new area of designing and testing bollards to help prevent storefront crashes that have been prominent in the news in the United States over the last several years. Those oftentimes yellow posts that you see at the Target and at the Walmart, they're literally just steel posts filled with concrete. There's no standard that anyone who installs those has to follow. And if you recall, or if you haven't seen it, if you can look it up, the Today Show actually did a test on what those devices can withstand, and you'd be stunned at how ineffective they are. They actually came to TTI and did the test, and we worked with one of our vendors with a stainless steel solution that would actually stop a vehicle at up to 30 miles an hour. So it's a matter of ANSI and other builders and builder standards getting on board. But as we sit here today, those yellow posts that you see, I wouldn't spend a whole lot of time loitering in front of them, to be quite frank. And I should point out, so in the top right, of course, that's just a true aerial picture, aerial photograph of what our position in the Brazos Valley looks like. You could almost see the Big Bend in the Brazos River at the top of the picture. That's the southernmost portion of the campus. That's called Goodson Bend. But that's how the runways and the taxiways orient. And interestingly, some of those hieroglyphics you see on that bottom center, That's the test ground for law enforcement training that our sister agency, TEACS, the Texas A&M Engineering Extension Service, performs. So over the years, just the rubber wearing away at the asphalt, at the concrete, just scouring away some of the algae that builds up, you can kind of see how dynamic that testing is. Industry partnerships. So shown on this slide are TTI's 3 initial industry partnerships at Rellis. 3M and our work together on smart pavement marking and sensors. Econolite, who's a sponsor of our smart intersection, and I'm proud to say that GRIDSMART has provided some technology and some cameras for that intersection as well. And Neology, which is constructing a high-speed toll testing facility at Rellis, scheduled for completion this fall. These relationships build on our longtime partnership with Trinity Industries in the roadside safety area. In the labs and in the classroom, TTI researchers are helping educate the next generation transportation workforce. And this is a poster session that we held following a recent gathering of engineering talent on campus. And I guess I should also point out the upper right, that is some testing that's being done on a strong wall that we have in that Center for Infrastructure Renewal. So that wall can take 1 million pounds of pressure. We have a strong floor. It's over 6 feet of solid poured concrete. So this Center for Infrastructure Renewal really is a 21st century marvel with respect to what we can do and what sponsors, clients, and stakeholders can do in that facility. Did I want to go here just? Yeah, yes. Okay, so we're now going to talk about our short course on behalf of TxDOT. So TTI is heavily involved in technology transfer. The annual Texas Department of Transportation short course has been held on the Texas A&M University campus since 1926 and hosted by TTI since 1950. We have nearly 2,600 TxDOT employees, researchers, consultants, and public agency personnel attend the annual short course, which is designed to share the latest transportation research and best practices from TxDOT-sponsored projects conducted by university-based agencies like TTI. And the others in state, of course, are the University of Texas Center for Transportation Research. We also work closely with Southwest Research Institute, as well as Texas Tech. They all participate in the university research program. TTI also hosts other types of workforce training on our research outcomes. As an example, state-of-the-art pavement seal coat workshops were recently presented in 10 locations for the Texas Department of Transportation, district's maintenance personnel, inspectors, and contractor superintendents. Army Futures Command, the Texas A&M University System, and the Army Futures Command have a new $65 million 5-year partnership to employ the expertise and assets of the A&M system on critical needs of the Army at the Rellis campus. Of special interest to TTI are next-generation vehicles, tactical network systems, possibly overlapping with V2I, or vehicles to infrastructure, precision navigation and timing, and the reliability and security of GPS or some parallel system. And this is General Mike Murray. So for those who don't know, the Army reconfigured its R&D effort under one 4-star flag command. So that flag flies at the UT campus, but the research campus will be out at Texas A&M. The Army was very much interested in working with the 2 flagship universities for the state of Texas, and Texas has proven to be very friendly toward the Army with significant military presence across the state. So we're also working with them on hypersonics and directed energy. Hypersonics is a category that's taken on increased significance as some of our global competitors have been able to deploy those systems. So it's basically projectiles at up to 7 times the speed of sound. So we'll be doing that research. And directed energy, for those of us who remember the phasers at Star Wars, that's good old lasers, as well as sound, directing sound and other kinds of technologies that are right now a twinkle in the eye, but in the very near term will be deployable in the field. So the Texas AV Proving Ground partnership, I alluded to it just a little bit. Texas has established an automated proving ground for the testing of connected automated vehicle technologies. Our partners in this effort are the Texas Department of Transportation, the University of Texas at Austin's Center for Transportation Research, Southwest Research Institute in San Antonio, and 32 municipal and regional partners across Texas. The A&M Systems Rellis campus will be a premier proving ground for this partnership. The governor of Texas has also formed a CAV task force earlier this month, which TTI is helping lead, to prepare the state for connected and autonomous, or automated, I think is the proper way to put it, CAV advancements. And also, for those who don't know, Senate Bill 2205, passed in our last biennium, literally opened the borders of the state of Texas for automated vehicle testing. So there's no need to register governmentally. As long as your organization has the proper insurance coverage, you can test vehicles as you like on the Texas roadways. So that's an invitation to show that Texas is open for business. So on average, we're talking about connected work zones now. 119 road construction workers have lost their lives annually in the U.S. over the last decade, with an average of 13 lives lost in the state of Texas each year. Now, this multi-year project is sponsored by TxDOT to develop research, innovation, and deployment in traveler information, mobility coordination, and work zone safety for a 96-mile, $2.1 billion construction project on I-35 in Central Texas. TTI has created an innovative, connected, real-time traveler information system that provides pre-trip and en route traveler information across, from Texas, en route traveler information across multiple you didn't laugh at that? All right, here we go. En route travel information across multiple outreach channels. This connected corridor, which is one of our automated proving ground testbed sites, has gained state, national, and international recognition, setting the stage for future research and deployment projects in this area. Wrong-way driving mitigation, big problem in the big western states, and it's a particular problem in Texas with our frontage road system. So TTI has conducted human factor studies to investigate the information needs of right-way drivers when a wrong-way driving event occurs, as well as design of wrong-way driver alerts displayed on dynamic message signs and through in-vehicle systems. Utilizing dedicated short-range communications, DSRC of course, radios mounted along the roadway to detect a connected vehicle as it entered a highway exit ramp from the wrong direction, TTI researchers have successfully tested a proof of concept CV wrong-way driving detection and management system at the Rellis campus. TTI also recently led a truck platooning project that was demonstrated at the Tti Proving Ground on the Rellis campus. Truck platooning extends radar and vehicle-to-vehicle communications-based cooperative adaptive cruise control using precise vehicle controls to maintain a tight formation of vehicles with short following distances. A manually driven truck leads a platoon, allowing the drivers of the following trucks to disengage from driving tasks and monitor system performance. Truck platooning has demonstrated the potential for significant fuel savings, enhanced mobility, reduction of emissions from platooning vehicles, and increased safety. The goal of the project was to develop near-term guidance for TxDOT and other stakeholders to prepare Texas for deploying truck platooning on key facilities across the TxDOT freight network. Smart highway infrastructure. As vehicle technology continues to expand into new areas, a need is developing to synchronize vehicle technology capabilities with traditional physical highway infrastructure. One of the most heavily used elements of the physical infrastructure space on a highway is pavement markings. Many new vehicles use cameras and machine vision, as we talked about, algorithms to detect and read pavement markings to provide features such as lane departure warning and lane keeping assist. TTI led a research project designed to develop pavement marking criteria that will provide reliable detection within vehicle camera systems. The results are being used by agencies interested in specifying and maintaining their highways to a level that will provide reliable machine vision detection. And here's a photo of just some of the connected automated vehicle research vehicles that we've developed. Researchers from Texas A&M University and TTI's sister agency, the Texas Engineering Experiment Station, TEAS, are developing the next generation of driverless vehicles, which are being tested at facilities on the Rellis campus. Experts from Texas A&M Engineering are collaborating with their colleagues at TTI to test the reliability, functionality, and safety of these vehicles. So the slide shows 4 of these vehicles. At the top left, it's an autonomous shuttle project underway in downtown Bryan, Texas, and that is an in-house developed automated vehicle. The top center is a Lincoln MKZ hybrid, which has been outfitted with a suite of sensors, LiDAR for object and obstacle detection, radar for detecting other vehicles, and cameras for traffic lights, signs, and pedestrian detection. The self-driving car follows a predetermined path based on GPS waypoints. The car autonomously travels at speeds from 20 to 35 miles an hour. And we also have a driverless shuttle on the upper right, which is being pilot tested on the Texas A&M University campus to examine scientific, engineering, and public acceptance factors associated with the introduction of autonomous shuttles on the campus. And the bottom photo shows the Texas A&M University College of Engineering students who placed second in an auto drive challenge sponsored by General Motors and the Society for Automotive Engineers. Texas A&M's team named the 12th unmanned, right, so the football, you get it, achieved the fastest performance time while successfully detecting and avoiding obstacles. And as I mentioned a little bit earlier, this is our Transformational Mobility Plan and Campus Transportation Technology Initiative. TTI researchers and staff are part of a large team that delivers game day transportation service for all A&M sports and many other large events, such as the Bush 41 interment ceremony at the Bush Presidential Library. The Campus Transportation Technology Initiative is pilot testing new transportation technologies on the campus, such as our automated shuttle. Through the Campus Transformational Mobility Plan, TTI is assisting in transforming the campus into a greener, more people-centric place by providing seamless mobility for students, faculty, staff, residents, and visitors. Regular stakeholder workshops are collecting input from these audiences. The top left is what's called a Dutch Junction, and that utilizes a phosphorescent paint, glows in the dark at night, on a challenging intersection on campus for vehicles and vulnerable road users to utilize to help guide the vulnerable road users more safely. We had a lot of media, actually that remains one of the most significant media coverage deployments that we had done at TTI. I had already mentioned the Mobileye, and you see the shuttle, but of interest for those who know about football in Texas, particularly this Saturday, I see the Alabama hat over there. Bryan College Station, when we don't have, so the university is huge. We got about 70,000 students. So being able to do this testing in this dynamic environment literally is a challenging urban scenario. So before the students come to town, there are about 250,000 in Bryan College Station. That goes up to 320,000 when they're in. And on football Saturdays, as you can see, Bryan College Station becomes the 4th largest downtown in the entire state. So it's quite dynamic, the ebbs and flows and managing all of that mobility and people movement. And you can see how busy our bus service is with those student drivers with 6.4 million annual transit riders. So rural transportation initiatives, this is a topic that often gets overlooked at many of our discussions and conferences about technology, about the rollout of automated vehicles, about connected vehicles, but it's an area we can't afford to overlook. So TTI is also focused on rural transportation initiatives. We're working with the A&M Health Center on a moonshot project and a smart dirt roads concept, among other things. Rural health care is an issue in Texas and throughout the country. We have 35 Texas counties with no physician, and 20 hospitals have closed in rural areas in the past 10 years. And also to get into some more numbers, we have 254 counties in the state, 172 are deemed to be rural. So just from the weight of legislative voting power, The power is not in the urban communities to affect the move and the adoption of advanced technologies. We have to bring the rural parts of our states into the picture. Last fall, Blue Cross Blue Shield of Texas and the Health Science Center announced a $10 million commitment to address this trend, and they asked TTI to participate to start thinking about what are the transportation solutions that will be impactful in providing health care in the rural parts of the state. So examples to be explored include automated technologies to enhance the operation of rural transit services, use of smart ambulances and unmanned aerial systems, and telehealth. So I'm also promoting a Smart Dirt Roads initiative that would incorporate the same smart roadway technology in rural areas that's being explored for urban areas, in part to enhance healthcare access, but also importantly to increase mobility in the disconnected parts of our states. And the challenge is, for those who work out on family farms and other farms, they have equipment. John Deere is out in front of this, as well as other farm equipment manufacturers that's fully automated. They have tractors they don't have to get in. They have threshers. They have combines. They can put down chemicals and materials with millimeter precision. And then in order to get to the post office, they got to get in their pickup and drive it themselves. So there's a disconnect for what technology can do in an uncharted field, but they can't get from point A to point B in their own personal vehicle without having to perform the entire driving task. And by definition, their distances are much greater, right? So now a 40-mile ride to the nearest town is something that a farmer or someone in the agricultural or a rancher is not looking forward to. So I would just submit that we need to focus our efforts and start to incorporate rural issues in our conversation about technology going forward. CAV benefits, I'm preaching to the choir, so as most of us in the room are probably aware, that was appropriate to say in this building, the U.S. typically has 38,000 plus fatalities resulting from roadway crashes each year, and 94% are caused by human error. So the full deployment of automated and connected vehicles, where human error is largely removed from the picture, holds the promise of fewer crashes and a dramatic reduction in the loss of life, as well as faster travel speeds, greater road capacity, optimized travel routes, and much more to improve lives. Self-driving vehicles move closer toward reality every day because many states and cities are now serving as testing grounds for these rapidly advancing technologies, and the list of locations is growing steadily. Legislators in 29 states have recently passed laws related to automated vehicles, and governors in 11 more states have issued AV-related executive orders. In addition to the safety benefits of CAVs, they also provide mobility for those who can't drive, such as members of our rapidly aging population, or those who have a disability, as well as other benefits, such as the opportunity to reduce congestion and emissions. So as we sit here today, there are 253 million cars on U.S. roads, and the average vehicle age is 11.4 years, which is the oldest in our history from a fleet perspective. So that means it will take at least 20 years for the existing fleet to turn over. Also, to make a profound contribution to safety, self-driving cars would need to constitute a dominant presence on the road, and we're still many years away from full deployment. So that means there's uncertainty ahead. There are still multiple hurdles to clear, such as the accuracy and reliability of these new technologies, the obvious need for ironclad cybersecurity, and the enormous costs of deployment. There are also uncertainties ahead related to consumer trust and acceptance and emerging policy issues. There is a hyper-competitive environment surrounding CAVs. Companies are keeping their plans close to the vest, so public agencies don't know what to plan for or the capabilities of the technologies being developed, and I would add whether or not they're interoperable. Independent organizations such as the Insurance Institute for Highway Safety have conducted objective testing of products, and automated vehicle technologies are still unreliable in challenging roadway environments and unexpected hazards, as you can tell from reading news accounts of AV crashes. Now, for routine driving situations, AVs are fairly reliable, but for unusual circumstances such as wet pavements, construction zones, high-density pedestrian areas, humans tend to be better than machines at making driving decisions at this stage of development. So from a policymaker's perspective, there's also a tension between protecting public safety and public interest while not inhibiting innovation that can accelerate societal benefits. It's a risk versus opportunity policy proposition. There's also a significant uncertainty over emerging policy issues that are not addressed in our current transportation code, such as data privacy, cybersecurity protection for both vehicles and infrastructure. And that leads us to the importance of research. So we have to remember that we're undergoing a transformation similar to the introduction of the Model T into a horse and buggy world, peppered with pedestrians, bicycles, and trolleys. So the state of technology is positive for certain, but evolving and still very much in development, testing, and acceptance mode. In research agencies like TTI, we're fond of saying more research is needed when we're forging a new path or developing a new product. This is exactly the case for CAVs, although we've come an incredibly long way in the last 5 to 10 years in preparing for the coming connected and automated vehicle revolution. For example, there's some research indicating that if we have a situation in the future in which everyone drives their own personal automated vehicle by themselves, or an extension of what we do today, people may not find their commutes as onerous, and they may actually drive more. This will result in more cars, more congestion, and more pollution. Exactly the opposite effects we would hope to experience with the benefits of CAVs. So our policymakers may want to find ways to support shared automated vehicles, such as an alternative to encourage multi-passenger trips. We're already seeing agencies subsidizing Uber and Lyft trips to connect travelers to high-capacity transit services that may not be currently convenient. We're also seeing the testing and deployment on public roads, first and last mile low-speed driverless shuttles. This is an example of piloting different CAV applications to learn as much as possible about the technologies themselves and public acceptance of the new technologies. And as our industry shifts to a CAV world, traffic professionals will need to have a more multidisciplinary background. Job responsibilities will be more data science and electronics focused, and flexibility will be needed by the boots on the ground workers and their management during the transitional years from an unconnected network to a fully connected network. ITS professionals will need an understanding of new design considerations, such as weather, landscape, population density, and how drone deliveries factor into the mix. Knowledge of freight data and logistics will be useful, as freight transportation is leading the way in CAVs to stay competitive. Vision-oriented leadership will be required to support CAV technologies, perhaps at the expense of more immediate needs. Departments of transportation and metropolitan planning organizations will need to partner with agencies like TTI and our counterparts across the country for workforce training in these new technologies. Future blended degrees and student internships among civil, computer, and electrical engineering will emerge. New specialty skill sets will also be needed, such as connected physical infrastructure and traffic information cybersecurity. Near-term actions, with what I like to call a mosh pit of change underway in this space. In the near term, it is important to engage all interests, public and private, to safely deploy and test technologies and support a continuous cycle of learning and innovating. This includes engaging the public in testing and deployment to understand acceptance and travel behavior shifts that will likely occur. Accelerate research to address gaps in understanding, which will affect all areas of transportation planning, project development, operations, and maintenance. Prepare to implement, which includes the appropriate policy and legal foundation for implementing automated and connected transportation initiatives. And I end every presentation with this slide because connected transportation is our future. TTI is focused on the interconnectivity of connected and automated vehicles, infrastructure, our mobility, our security, and how this new future will affect our daily lives. As I believe we all realize, we're on the leading edge of the deployment of a fully connected transportation system, and all of us in this room will play a role in its implementation moving forward. So thank you again for inviting me to participate in this forum. If I left any time, I tell you I'm a lawyer, I can get long-winded. I'm happy to answer any questions that you may have. Yeah. All right. Thank you.
Let me bring you the mic. We, at TRB, where we've met on many occasions, we have talked about the importance of retraining workforce, training new workforce, and offering different sort of degrees. How important in this whole conversation is citizens' engagement? Does it all start with citizens' engagement? And if it is, what is it that TTI is doing, for example, to engage those rural communities? I think you had one slide, but that's just a tiny bit of the conversation that I don't hear enough. And yet, when we go to conferences, it's always talked about the workforce, it's deployment of workforce. It's really, really important. But where do we start, and how do we get our engagement of our citizens?
That's a great question, and that is a critical component. You know, part of what happens at these conferences is we're all in this industry, and we're talking amongst ourselves, but the word isn't getting out to the public as to what the benefits potentially are, what the future looks like, what's coming down the pike. I'm always reminded of a commercial by a tire company that had a baby sitting in the middle of the tire, right? So any parent that saw that wasn't going to buy that company's brand of tires. So part of it is messaging. Part of it is using public service announcements just to get the word out. If you remember even farther back, the Chemical Manufacturers Association had that guy with the little blue guy with the hard hat talking about how it was cleaning up the industry, right? So these kinds of simple images paint a long picture and cast a long shadow. And to go even farther back, being from New York as a kid, there used to be a commercial about anti-jaywalking, and it was cross at the green, not in between, right? So simple messages again, to start to get the word out. You can't do it all at once because it's a lot to absorb, but put it in a form and fashion that the public starts to understand how this is going to benefit them. And it has to start with our major organizations like TRB. I mean, I don't think companies can do it with respect to their technology platform, so I think that's important. But I don't think companies in this space advertise, right? They're in the trade publications, which means we're still talking amongst ourselves. So we have to work with our national organizations, our trade associations, to start to think prospectively about educating the public so that the uptake and acceptance is positive. Because as we saw from the incidents with vehicular crashes with automated vehicles, the minute there's one crash, regardless of who was involved or what the cause was, it was, hey, an automated vehicle crashed, right? Boy, this is a bad idea. So we can't afford to have negative hits at the front end because that will just make uptake even more difficult and stretch out the timeline. That's a great question. All right. Thank you so much. Yep. Every time I...
Got a lot of people outside, so we need the microphone.
Oh, yeah.
I was curious about the remark you made when you said if people go back to enjoying an automated vehicle experience simply because it makes their life easy, I think you said less onerous, that they might actually purchase more vehicles. I was kind of curious as to how you arrived at that, and that was interesting. I've yet to ever hear anybody speak to that. I've only ever heard them say, you know, ride sharing the Lyft, but not the idea that there could be more cars as a result of them being easier and more, I don't want to say pleasurable, but, you know.
Right. Well, the thinking behind that is, you know, if it's less onerous to live far away from work or far outside a city, and it's less expensive, why wouldn't you, right? So if you don't have to engage, if your commute is 2 hours, but it's not 2 hours of white knuckle, you know, saluting your neighbors with one finger, it's a different proposition what a commute looks like. So even though the trends are people are condensing into city centers, That's not to say if technology makes it more attractive that you won't see the opposite explosion rather than an implosion. So that's part of the challenge. And I think also the lesson of what you're seeing from the transportation network companies kind of belies the fact that they are providing a congestion solution, right? And part of it is, we talk about the shared economy. It's not the shared economy, it's the I'm not driving economy, right? So we're still very much locked into one person, one vehicle. It's just that that one person is now in the back seat letting the Uber driver drive. So that's why you're seeing cities like New York reduce and put boundaries around how many of these licenses they will allow to circulate in the city because they saw increased congestion. So that's a model, which I think is directly applicable to not having a driver, right? Because the occupant is not engaged in the driving task. They're doing what they want, they're reading, they're texting. That's what we say they're going to be doing in automated vehicles. So if we can predict what we're seeing from the TNC explosion, I think it's a logical leap to foresee more congestion on our roadways because we can't build our way out of our problem. Now, there is a flip side to it. Maybe then you don't need a 12-foot wide lane if vehicles don't crash and they have the ability to ride in closer formation, right? So now a 2-lane interstate becomes a 3-lane interstate. That's a solution, but that's a minimal solution if you look at population growth and the expectation of what exciting new technology brings to the table.
Question over here. You mentioned the wider pavement markings having a benefit not only for the CAVs, but I also see that as from a human driver, that also having that side benefit as well. What other, I guess, priorities or research have you seen that are kind of coming out that would both help the human driver and in the future, as you mentioned, the transition of getting rid of the existing vehicles and then transitioning into the CAV? What other items are kind of on the forefront that TTI is kind of looking at as far as CAV?
Well, your point about any benefit to a machine vision vehicle benefits a human vision vehicle, right? So that's been part of our work with 3M. So we're working on retroreflectivity. We're working on embedded messaging in signs that can provide data into the vehicle. So I think you'll see increased data streams that benefit human drivers. The reason we're so focused on human factors is you can't get to the point where it's clutter, where it's too much information creates problems rather than provides solutions. So we're looking at it from a data science perspective. We're looking at it from, again, the retroreflectivity, classic standard work in that space. I think those are areas that you'll see. There's a big question as to whether or not vehicles will have steering wheels, as you heard, right? So we look at that from what does that mean for human drivers that are in a self-driving vehicle that need to take control? So there's a lot that's going on. We're also looking at what I've been calling 4D traffic management. So as Uber Elevate starts to experiment with their flying people mover, and as drone delivery becomes more of a reality, I think UPS just got preliminary approval from DOT for drone deliveries. We've got to figure out right now traffic management is on a 2-dimensional level, right? It's going to need to go to 4D, and the reason I say 4D, yeah, it's 3D spatially, but the 4th dimension is time, right? Because you have to have accurate time to be able to predict where a device or where a vehicle is. So if you can imagine in the near term, if a human is being flown from point A to point B and a pizza's going from point C to point D, and at some point they need to work their way down from altitude to the people level, right? Some of these vehicles they're talking about are going to go from flying to driving, right? So what does all that look like? How do I, in my flying Uber Elevate, merge onto I-40, right? And the vehicles around me now know that there's somebody above trying to come in and merge. So it's going to be awful complex. And we don't hear a lot of conversation about how do you manage that. So that's what I mean about 4D traffic management. We want to put together a straw model for folks to improve upon, at least to get the discussion going, because the future of mobility is going to be incredibly complex. So that's some of the outlier things that we think about and look at, but we're also still heavily invested in pavement materials. You know, it's about roads and bridges and maintaining the infrastructure that we have, keeping it in a state of good repair. That's a key challenge, particularly in an environment with shrinking governmental dollars, right? So getting more investment and more ownership amongst private organizations and others to help really buttress what government is supposed to be doing is also going to be the model for the future. So we look at that from a policy perspective. How is that going to work? Great. Yes, sir.
So with autonomous vehicles being easily accessible, how does that prevent like a child from just saying, I'm going to get in this automated vehicle and going downtown and somehow, you know, without parents' permission or whichever, child lock safety? I mean, with the Uber driver has every right to say no.
Right, right.
Then again.
Well, you know, you're starting to see things like retinal scans and fingerprint identity and biomarkers. I'm not so concerned about unauthorized access to automated vehicles for human access. I am concerned about cyber intrusion and privacy issues, because it's still unsettled as to who owns the data and the data stream that a vehicle produces and to what ends can those be used, right? I mean, those of us who are private citizens don't want a law enforcement envelope over that data. But for those of you who have a Ring doorbell on your home right now, there's about 500 police forces across the country that right now it's voluntary. They're saying, will you opt in and be part of our crime solution package so that we can see everything going on your street when it's contiguous with all of your neighbors, right? So, I mean, that's a clear instance of where access to data has a beneficial, you know, it has a beneficial use because we're all law-abiding citizens, right? But, you know, do you really want to be watched and have the potential to be watched at every instance? That's a slippery slope. So it's those kinds of thoughts and challenges about particularly the ubiquity of data. You know, if you hear what folks are talking about in the mobility space now, mobility is the safe and efficient movement of people, data, and goods, right? And you've heard data is the new oil from The Economist and others. So the uncertainty, the ubiquity, and the tsunami of data that will be unleashed when all of these vehicles and all of this roadside infrastructure is equipped is going to be a tremendous challenge, and I think that's the bigger issue that we should be keeping our eyes on. But if your little brother wants to hop in the self-driving car, I wouldn't worry about it too much. Unless he's going to change your radio station. All right. Well, thanks, folks. I appreciate it. Thank you.